Okay, so in this exercise we're gonna find out if an equation um, it's a function. So the strategy that we need to apply in this type of exercise is in step one we solve the equation for y, and then we're gonna look at the formulas for y, and if we have one formula for y, then we have a function. If we have two or more formulas for y, then this equation does not give a function. So let me show you these examples, and then I'll give you guys another example uh, to describe this better. Okay, so let's do part A. So in part A we notice the equation is already solved for y. So the equation is already solved for y. And if we look at this equation, then we can see that there's only one formula. So when these two conditions are satisfied, then we can conclude that we have a function. And if you're going to see it, that this is indeed a function by using graphs, we could graph it and then using the graph we could apply the vertical line test. So we can also graph this, and in section 2.6 then we cover these functions. This is the function that passes through -1 comma -1 0 0 and 1 comma 1, and as you may recall, the graph looks something like this. So this indeed passes the vertical line test. We can draw vertical lines, and these lines only touch the graph at one point, and so this is a function. Okay, so now let's do part B. Okay, so in part B, and we're actually going to use let me move on to another page to do this part B. So okay, so for part B we're looking at the equation x equals y to the 9. So we're trying to find out if this is a function, and so step number one is we solve for y. Okay, here we can solve for y by applying the ninth root to both sides of the equation. Okay, apply the ninth root, and so this will cancel the power 9. We get y equals the ninth root of x, and we have so this is solve for y. Okay, and notice And step 2, we're supposed to count the formulas for y. There's only one formula, okay, for y, and so these two conditions are satisfied. So again, we have a function. So you may be asking yourself, okay, when do we have an equation that's not a function? So let me answer that here. So then, when do we have? So when do we have an equation that is not a function? Okay, so here's the answer. So if you look at the equation, x equals y to the power 2, and we solve for y. Here we can solve for y by applying the square root, but we remember that when you apply an even root, like a square root, the fourth root, the sixth root, we have to use the plus and the minus. So when we solve for y, we get square root of x equals y, but because we have the plus and minus, we actually have to use also the negative square root of x. So in this example, we have two formulas for y. So this is a case when this equation is not a function, and if you wanted to graph this um, equation, you will find out that the graph of this equation is a parabola which is sideways opening to the right, and so you can apply the vertical line test and find out that this is not a function. Okay, so once again, you guys, step number 1, you solve for y. Step number 2, you count the number of formulas that you have for y, and if it happens that you have one formula, then you have a function. Otherwise, if you have more than one formula, like in this last case, in this example, then the equation does not provide a function. I hope you guys understood this example. Let me know through Canvas if you guys have any questions.